Nature is the best classroom and curiosity is our guide. Good morning everyone. Myself Kaive Darshni from the KUMARI Arivial Peravai, the Young Scientist program, and we are here at Kadiapattinam Estuary to analyze the effects of freshwater and saltwater mixing and its direct influence on the stability of the ecosystem and the local community livelihood.
I'm Joanna. I'm very happy to be here. This estuary feels like a classroom under the open sky.
Hello everyone, I am Evalin. It's so interesting to see how rivers and seas mix. Nature itself is teaching us today.
I'm Ranjana. I feel excited to land here. Every ripple in the water tells a new story.
This is Akshar. I'm proud to join this study. This estuary is not just water, it is a lifeline for a local community.
Hi, I am Sudhin. I am amazed by what we see. The mixing of freshwater and saltwater are fascinating.
When river meets the sea, life begins, but only if we protect it. Nature speaks to us quietly through water, wind, and living organisms. Estuaries are places where this voice is strongest because here the fresh water and salt water meet, mix, and create one of the most productive ecosystems on earth. But today, this natural balance is under threat due to the human pressure and pollution.
Local ecosystems support local lives.
The Kadiapattinam Estuary is an important coastal ecosystem on the southern coast of Tamil Nadu, where the Valliya River meets the Lakaveri Sea. The estuary stretches for about 2 to 5 kilometers. It changes over the seasons. This estuary is surrounded by human settlements covering for about 1,926 hectares, with around 26,500 residents. Forms the socio-economic context of the estuary. A portion of the population lies on sea and estuaries, fishes, and water resources. The mixing of fresh water and seawater forms a unique blackish environment, including a saltbed system which supports rich biodiversity. It is surrounded by coconut trees, riparian vegetation, marsh grasses, and other salt-tolerant grasses. Marsh plants and coconut trees stabilize the banks, while black sand deposits shows natural sediment movement. The estuary acts as a nursery ground for fishes such as catla, local species like mala and slopia, along with crabs and prawns. The estuary also supports the presence of various bird species. This fragile ecosystem supports fishing, agriculture, and daily activities of the local population, making conservation essential for both nature and human livelihoods.
Our young scientist study. Observation is the first step of scientific discovery. Our study aimed to observe water quality changes, mixing patterns, and human impacts on estuary. We observed basic parameters such as temperature, turbidity, freshwater inflow, tidal inflow, water movement, and visible mixing characteristics, and human activities near the estuary were carefully recorded. We collected 6 water samples, 2 from the freshwater zone, 2 from the estuary mixing, and 2 from the estuary mouth for further chemical and microbiological analysis of water.
What we observed: water temperature and salinity change with time and location. Our observation and interview with local community revealed clear environmental variations. The water temperature increased from around 20 degrees Celsius in the morning to about 25 degrees Celsius by late morning, showing the effect of solar heating. The mixing zone appeared highly turbid, indicating suspended sediments caused by river flow and tidal action. Salinity gradually increased from the riverside towards the estuary, mouth and sea. Water color varied from light brown to dark patches, suggesting pollution and organic waste input. Low to moderate wave action was observed near the estuary mouth.
Pollution leaves visible and non-visible scars on water bodies. The estuary water quality shows clear effect of seawater and freshwater mixing and increasing pollution stress based on measure values. The pH range of 7.0 to 7.7 indicates a stable and suitable environment for aquatic life, while salinity around 16 ppt come from brackish conditions. Dissolved oxygen average 6.8 mg per liter, which is adequate for fish and shellfish, but slightly lower than open sea water, suggesting active biological and organic process. Nutrition loading is evident from nitrate concentration reaching 2.7 mg per liter and ammonia level averaging 0.235 mg per liter, indicating inputs from runoff and organic pollution that may stress aquatic organism if level rise further. Iron concentration up to 0.10 mg per liter may influence water clarity and habitat quality. Microplastics are present at the average concentration of 0.40 mg per liter, higher than a typical freshwater and marine values, reflecting accumulation due to estuary mixing. Although not an immediate toxic threat, this level of microplastic represents long-term pollution pressure, confirming that the estuary acts as a sink for condiments, with potential future impact on fish health and local fishers.
Healthy ecosystems support healthy communities. Changes in water quality directly affect aquatic life. We observed fewer fish in some parts of the estuary, which has forced fishermen to move towards the sea for better catch. Estuary water is still used for agriculture, but increasing salinity and pollution can reduce soil fertility and crop yield. When estuary health declines, the livelihood and food security of local communities are also threatened.
Since ecosystems take decades to recover once damaged, conservation is not a choice but a responsibility. Conservation focuses on reducing pollution through trash traps, limiting plastic waste, and managing domestic wastewater. Designated washing areas, soak pits, constructed wetlands, and riparian buffer zones can treat grey water before it enters the estuary. Stabilizing banks with native salt tolerance, grasses, and riparian vegetation traps sediments, purifies water naturally, and provides habitat. Seasonally, seawater intrusion increases salinity and reduces summer river flow, forms sandbars, causing stagnation and brackish water. These are managed by maintaining minimum fresh water flow, controlled sandbars opening, and debris removal. Large stone revetments prevent soil erosion combined with vegetation, maintain shoreline stability. Regular monitoring of water quality enables early detection of stress. Community participation, especially by local youth, in cleanups and sustainable fishing strengthens livelihoods and socio-economic resilience. Small actions today can create a big impact tomorrow.
This is our closing line, a promise to nature. The future of nature depends on today's action. The Kadiapattinam Estuary is not just water, it is life, livelihood, and legacy. If we protect the estuary today, it will protect us tomorrow.
We gratefully thank Mr. Mullancheriam Velayan, organizer, KUMARI ARIVIAL PERAVAI, our guides, Mrs. Danya ma'am and Mr. John Kumar sir and the entire team for their inspiring guidance. We also thank our parents for their unwavering support in making this study possible.